Hello, girls. I hope you're having a great day and you're staying safe at home. To continue with the alkane chapter, today I'm going to talk about the laboratory preparation of methane. Okay, so the reactants required for the preparation of methane in the lab are sodium acetate, okay, and soda lime. Now sodium acetate is CH3 COO Na, and you take soda lime. You know soda lime is sodium hydroxide. Okay, so soda lime is taken in the form of a white porous mass or granules. It is a mixture of sodium hydroxide and calcium oxide. Now, the procedure you need to follow is you have to take a mixture of sodium ethanoate or sodium acetate and soda lime in a hard glass test tube. Okay, this is the hard glass test tube, and it is heated with a Bunsen burner. Okay, now the reaction sets in, and what will be produced? You will see in the reaction a delivery tube leading down into a beehive shelf, and then the gas methane is collected by the downward displacement of water. So here you will see that the reaction between sodium acetate and soda lime, okay, soda lime, you know there is a dash of calcium oxide also mixed with it. Okay, so we heat it to 300 degrees Celsius, and the product is sodium carbonate, and methane gas is given out. Okay, so you saw the gas evolved is collected by the downward displacement of water. Why? Because it is slightly soluble in water and it is lighter than air. Okay, next, moving on to the laboratory preparation of ethane. The reactants taken are sodium propanoate or sodium propionate, that is C2H5COO Na. Okay, and again you need to take soda lime. Okay, what is mixed with soda lime? You know calcium oxide, and similarly you have to heat it to 300 degrees Celsius, and here what will the product be? Sodium carbonate, and we are preparing ethane, so ethane will be evolved. So it is collected in a similar manner, that is by the downward displacement of water. Okay, other methods of preparation of ethane and methane are: the first one, methyl iodide, also known as iodomethane, and bromoethane or ethyl bromide are reduced by nascent hydrogen. Now, nascent hydrogen means one atom of hydrogen which is produced by the action of zinc powder on dilute hydrochloric acid. So we take iodomethane and nascent hydrogen. What do we get? We get methane and hydrogen iodide. Okay, so when we balance, nascent hydrogen is written inside square brackets. Or if we are preparing ethane, what do we take? We take bromoethane, and this also reacts with two atoms of nascent hydrogen to give ethane, because that is what we are preparing, and hydrogen bromide. Okay, and another method is when water is added to aluminium carbide. When you add water to aluminium carbide at room temperature, you will get methane and aluminium hydroxide, which is a precipitate. You know, methane is a gas. Okay, so when we balance it, we get 12 molecules of water, 3 molecules of methane, and 4 molecules of aluminium hydroxide. Okay, another method of preparation of ethane is when methyl iodide is warmed with sodium metal, okay, in the presence of dry ether. What do you get? You will get ethane, that is C2H6. You can also write it as H3C-CH3. That is ethane, okay, and you will get sodium iodide. So when you balance it, you will see 2 molecules of methyl iodide, 2 molecules of sodium, and 2 molecules of sodium iodide will be required. And this particular reaction, remember, it's known as Wurtz's reaction. So you may get a question where you are supposed to write the Wurtz's reaction. So this is the Wurtz's reaction. Now we cannot prepare methane by this method because it is not suitable for preparing alkanes, which has odd number of carbon atoms. Next, you are going to learn about the physical properties of both methane and ethane. Okay, so the physical property of methane, you know that it is a colorless and odorless gas. It has no smell. Then its melting point is minus 183 degrees Celsius and its boiling point is minus 162 degree Celsius. Okay, that is the first one. This is the second one. And the third one is, it is negligibly means it dissolves, but like you can ignore it. It is negligibly soluble in water, but it is soluble in organic solvents. And the physical properties of ethane, it is colorless, odorless, does not have any smell, tasteless, does not have any taste, and it is a non-poisonous gas. Okay, so next is its boiling point is minus 89 degrees Celsius and its melting point is minus 172 degree Celsius, and it is sparingly soluble in water. That means it dissolves more than methane. Okay, it is sparingly soluble, but it is wholly soluble in, again, wholly soluble in organic solvents. Okay, so example of organic solvents are alcohols, acetone, ether. So it dissolves in organic solvent, but it is sparingly soluble in water, whereas methane is negligibly soluble in water. That means it dissolves in water to like very less that we can even ignore it. Okay, we'll stop here, children. In the next upload, I am going to talk about the chemical properties of methane and ethane. You know, methane and ethane are saturated hydrocarbons. Okay, so have a nice day, children. God bless you.